In this example, we're asked to describe the end behavior of each polynomial. Again, this comes back to the same problem as match problem 3. End behavior, finding the limit as x approaches positive infinity, negative infinity. Those two problems mean exactly the same thing. And what we're interested in is just the leading term. So in this case, even though they're not written in descending order, this second term is actually our leading term. So it's not about which term comes first, but which term has the largest exponent. So all we're really worried about in this case is the limit as x approaches positive infinity of negative 4 x to the fifth. In this case, as x approaches infinity, we're plugging in larger and larger positive values, taking that to the fifth power, so that part's getting very large very quickly, and it's a positive number. Then we're multiplying that by negative 4, so negative times positive gives us negative infinity in this case. And we can consider the limit as x approaches negative infinity of negative 4 x to the fifth. In this case, we're taking negative values, plugging those into x to the fifth. A negative number raised to the fifth power is just going to be a smaller negative number. So x to the fifth is headed to negative infinity as x goes to negative infinity. But then we're multiplying that by negative 4. So our negative times our negative gives us a positive infinity. So this polynomial has different end behavior at each end of the graph. In part B, the process is similar. We're interested in just the leading term, so in this case 300 x to the sixth. So we consider the limit as x approaches infinity of 300 x to the sixth. We're plugging positive values into x to the sixth, so that's approaching positive infinity, times a positive number is approaching positive infinity. We consider the limit as x approaches negative infinity of 300 x to the sixth. We're taking negative numbers, plugging those into x to the sixth. That even exponent is going to make those values positive, so that part's heading to positive infinity times a positive 300 is equal to positive infinity. So in part A, different end behavior at the different ends of the graph. In part B, the same end behavior at each end of the graph.